Welcome to 6.1 inverse circular functions. We're going to look at example 4a. Find y in radians if y equals secant inverse of negative 4. So if we're looking at y equals secant inverse of negative 4, most calculators do not have secant and secant inverse, so we're going to need to use its reciprocal functions. However, we can't use its reciprocal functions as an inverse. We have to convert it into a regular function, and then we're able to convert it into using its reciprocal. So first step, we will go ahead and write secant inverse of negative 4 equals y as a regular secant. So we get secant y equals negative 4. Now we are able to convert this into a cosine because we have a regular secant function. So if I know my secant, my cosine is just the reciprocal of that. So we get cosine of y equals negative 1/4. Now I can go ahead and convert my cosine of y into an inverse. So y equals cosine inverse of negative 1/4. If I put that into my calculator, I get 1.8235. Now, one might ask, well, what does this even mean? First of all, we notice that secant inverse has to be 0 to pi. Remember, pi is about 3.14. Also, we have here that the cosine of y is negative, so we know we need to be somewhere here in quadrant 2. And this 1.8 is more than pi over 2, but less than 3.14 or pi. So we end up, this angle right here is an angle in quadrant 2. B, find theta in degrees, where theta equals arc cotangent of negative 0.2528. So let's first notice that arc cotangent must be in between 0 and pi. Now, let's convert. Cotangent of theta equals negative 0.2528. So now we can say, oh, well, cotangent isn't in the calculator, but tangent is just going to be the reciprocal, 1 over negative 0.2528. So now we're ready to, now that we have tangent of an angle, we can find that angle by using the inverse of tangent, making sure to put 1 over negative 0.2528 into the calculator. Now, usually with inverses, we give our answer in radians. However, this specified to give it in degrees. So we'll make sure we're in degree mode. And we get negative 75.8 degrees. Okay, well, this is weird because we are expecting our answer for a cotangent to be 0 to pi. But remember, the calculator only knows that we're putting tangent inverse into the calculator. So our tangent gave us a value that was negative pi over 2 to pi over 2. So here, the reference angle is 75.8. So this reference angle is very relevant. What we need to do is we now need to transfer this information and now say, well, we know if the cotangent is negative, it must be in quadrant 2. And so therefore, my reference angle is still going to be 75.8. So to find this angle right here, from 0 all the way to this right here, we're going to need to take 180 degrees and subtract off that 75.8 degrees. So our final answer is 104.2 degrees, and that is the theta. This is a very strange situation, and the only time we have to do this is if we're trying to use a calculator for cotangent, or for arc cotangent or cotangent inverse. So all others, because the reciprocals are normally together in the same range for our inverses, we're fine. It's only when we need a calculator for arc cotangent or cotangent inverse. Example 5. Evaluate each expression without a calculator. A, cosine of sine inverse of 2/3. So the first thing to ask is, what does this sine inverse of 2/3 even represent? All of our inverse functions are actually equal to the angle or the arc length. So what we're going to do is we're going to go off to the side and we're going to let theta for an angle be sine inverse of 2/3. So now, if this whole inside sine inverse of 2/3 is now being called theta, we're really just looking for cosine of theta. Well, how is this supposed to help us? Well, because we're saying theta equals sine inverse of 2/3, we can convert that to sine theta equals 2/3. Aha! So now we could either use the Pythagorean identity, or we can go ahead and graph it. Because it's a sine inverse, I'm limited to quadrants 1 and 4, but it's positive, so it will be in quadrant 1. My sine is y over r, so I get 2 is my y and 3 is my r. Now I just solve 2 squared plus x squared equals 3 squared, or I get x squared equals 5, so x is plus or minus rad 5. Therefore, x will be positive rad 5 since I'm in the first quadrant. Now all I need to do is calculate the cosine of theta. Cosine of theta is x over r, or rad 5 over 3. And it will be positive because it's in quadrant 1. So anytime you have these composition of functions, you always want to find the inverse or the arc cotangent and declare that to be your angle. And we'll call that theta or A and B. B, secant of cotangent inverse of -15/8. So we first identify the inverse. So our theta will be cotangent inverse of -15/8. So now we have to be careful of what quadrant we are in. Because we have cotangent inverse of a negative, remember cotangent inverse will give us a value between 0 and pi. So since it's negative, we'll have our angle over here. We'll also rewrite this as cotangent theta equals -15/8. So recalling that cotangent is x over y, we will have our x value be -15 and our y value be 8. Now we go ahead and solve x squared plus 15 squared equals r squared. We get 289 equals r squared, or r is plus or minus 17. Since it's a radius, our radius is always positive. Now going back to the original, we are looking for secant of this quantity, but notice this quantity here is just theta. So this actually equals secant theta. So now let's go ahead. Remember, secant is just the reciprocal of cosine. So instead of x over r, it will be r over x. So our final answer is 17 over 15. The negative, we want to make sure we don't leave it on the bottom. So the final answer is -17/15. Your negative could be out front or on top, not on the bottom. I'm going to add example C, sine inverse of cotangent of -pi/4. So first you might notice inside we actually have just a regular function. So let's start by finding out what is the cotangent of -pi/4. -pi/4 is going to be in quadrant 4, and using triangles we get x is 1, y is -1, r is rad 2, since it's a 45 reference angle. So cotangent of -pi/4 is 1 over -1, x over y, or just -1. So that leaves us this being equal to sine inverse of -1. Remember, we want to have our inverse equaling an angle theta. So we're going to say theta, we'll just allow this sine inverse to equal theta. So we can rewrite this as sine theta equals -1. Recall our sine inverse must give us a value, one value, from -pi/2 to pi/2. If sine is 0 or plus or minus 1, then we know theta will have to be a quadrantal angle. So where is sine a -1? And that's down here. Because our coordinates are 0, -1, that means our sine is a -1, and that's at the angle of -pi/2. So our final answer is this whole thing will equal -pi/2. Because notice I got theta equals -pi/2, but that's what the sine inverse equaled, which is equal to that right here. So our final answer is -pi/2. I hope you enjoyed this video. See you next time.